Hello everyone, I am Goutham Surendran. I am a second year Btech student at Amrita Vidyapeetham, Amritapuri. So in this video we will be talking about a question called same tree. It is a data structure problem. So this is a question related to binary trees. So before jumping into this problem, I'd like to introduce what a binary tree is. What is a binary tree? It is a data structure in which each node will have at most two children and are referred to as left side and right side. So these 3 and 10 are the children of 8. It is 3 is the left side, whereas 10 is the right side. The topmost node is called the root node. That is, this 8 here is the topmost node and it is called the root node. And if a node has children or a child, that is 8 has got 2 children, that is 3 and 8, 10. So it is called a parent node. If it does not have any children, it is called as a leaf node. That is 1, 4, 7 and 13. Since 1, 4, 7 and 13 does not have any children, they are called leaf nodes. Each node contains a specific data. Okay, since it is a data structure, it is designed to contain data. There are also different types of binary trees. Binary heap, binary search tree, AVL, and for the scope of this video, I'm not going to discuss 3 of those. We'll be sticking to our binary tree. Okay. Understanding the problem. So in the question, we are given 2 binary trees. The objective is to find out whether both the trees are same or not. We have to print true if they are structurally identical and all their nodes contain the same value. That is, if they look the same, that means each node has got the same value and they are structurally identical, we have to print true, otherwise we have to print false. In the first example, we are given 2 trees. First tree is 1, the root node is 1, its left child is 2 and its right child is 3. The second tree, the first child is 1, the root node is 1, the left child is 2 and its right child is 3. So they are structurally identical and each node contains the same values. So if we put it into a list, it would be 1, 2, 3, 1, 2, 3. But the output we have to print is true. So in the second example, we have got 2 trees. The root node of the first tree is 1 and its left child is 2. In the list it will be 1, 2. And in the second tree, the root node is 1 and its left child does not exist, so it's null. So the left child of the root node is null and its right child is 2. So they differ structurally, right? One is skewed to the left and other is skewed to the right. So they are structurally different. So it is not the same tree. The output we have to print will be false. Okay. And the third example, we've got 2 trees, 1, 2, 1, 1, 1, 2. At the first glance we get to see that these are not the same trees. The left child of the root node is 2 here and the left child of the root node is 1 here. So that's 1, 2, 1 and 1, 1, 2. So it's false. So we will be solving this problem in a recursive algorithm and the time complexity will be big O of n. So in the code we have to check mainly 3 conditions there. We have to first check if the first node of both trees are null. That is, in this example, if here it was null, it did not have any children, and here it was null and it did not have any children, they are basically like the same tree, right? So that is our base case for this recursive algorithm. Okay, so we have to return true. And the second is check if the first node of only one of the tree is null. Suppose if it did not have any children, this did not have any children, and it was 1 here, and suppose here it is null and it does not have any children. So here it is 1 and here it is null. So they are basically not the same tree, and therefore we have to return false. And the third condition will be to check if the subsequent nodes of both the trees have the same value. That is, we have already checked for the root node. We have to go to the second one. That is the left side. If the left child of both trees are same, we have to print true. Not print true, we have to check for the subsequent nodes. Also we have to check to the right, and if all these conditions are satisfied, we have to print false. Okay. Okay, before I'll just show the code Okay, this is the initiation of the or the definition of the node class. The value is where you store the data, and here this is the left child, that node or whatever. This is the right node or right child, and this will be tree node integer. This is the constructor for assigning the value. Whatever value of passing, the constructor should be assigned. Okay. Public class solution. This is our solution class. Here, this is where we are writing our solution. So since we have to return whether true or false, our method will be a Boolean method. So do public Boolean each same tree. We are passing the root nodes of both the trees. That is the first tree and the second tree. We will be passing the root nodes, and first we are checking for our first condition. If p equals null and q equals null, that is, if both are null, as I said, they are basically the same tree or non-existent tree. But it's the base case for the recursive algorithm, and we are returning true. If p equals null and q not equals null, or q equals null and p not equal to null, that is, one is null and the other is not null. That is, one node is null and the other is not null. It's not the same tree. That is the root. One is an empty tree and the other tree has got a node, so it is not the same tree. So we have returning false. That is our second condition, and we'll also be checking if p dot value or p not equals q dot value. That is, if both are not null and has got value in it, we are now checking that if both has got the same value. If it does not have the same value, we are returning false. So it is not the same tree. Okay, and our recursive call will be here. That is, this is our recursive statement. This is where the recursion will be occurring, and all these steps will repeat with this p dot left, q dot left as the node, and p dot right, q dot right as the node. And it will check for the AND condition, that if this is true and this is true, it will return true, and if this is true and this is false, it will return false. Okay, so I'll explain that with okay. Suppose, here we're checking at the root node. This is not null, this is not null, and here we are checking if they are equal. They are equal, right? So we'll call the function as recursive function at left for the left side. Okay, we are checking the value is not, if the value is null. Since it is not null, we are checking if it is same. Here both the values are same. Also, we'll also check for the right, and we'll check if it is null or if it has got the same value. Here also the condition is satisfied. Here we'll check. Then now we'll go for the left child of this. We'll pass this into the recursive algorithm, and here it will be null, and here the left child will be null. Here it is not null, but its child will be null. Okay. We're checking for this like left, right. For each one we're checking, and what is happening is, if this condition is satisfied and this condition is satisfied, then they are both compared, and we are returning a Boolean value, that is true or false. So that is basically how we find out if the tree is same or not. I hope you have understood, and feel free to ask doubts in the comments or whatever. Thank you.